In this video, we're going to look at continuous probability distributions. So a probability distribution can be defined by a function. And if it's continuous, then that function will qualify as a probability distribution if it meets the following criteria. So first off, the values have to be greater than 0 for the entire domain as the function is defined. The area under the curve for its entire domain needs to be 1. So here I've written the integral from negative infinity to infinity, but if the domain is restricted or bounded, then the integral would have those same bounds. This area needs to be 1 because the area correlates to the probability under the curve. So if I have a curve that looks like anything really, it has to be fully above. So anywhere it goes down, so let's say I've defined it here, that total area under that curve must equal 1. The mean of that distribution will therefore be the area, the integral, remembering that an expected value would normally be defined as the sum of all possible outcomes times their probabilities. But because this is a continuous distribution, I can't really do that manually, but an integral does represent a sum. So if I multiply the x value times the f of x value, which is representing the probability, then I will get the expected value if I integrate over the entire domain of the function. And for the variance, same thing. Variance, normally I would take the differences between each value and the mean squared, multiply by their probability and add them up. Because this is continuous, I need to use an integral to do that summation. So let's consider this probability distribution, I don't know yet that it is a probability distribution function. I have a function. It is continuous between 0 and 2. The function is defined as 0 elsewhere. And I can see that this is like the 3/4 x times 2 minus x is a quadratic. It's a parabola that crosses the x-axis at 0 and 2, and because it opens downward, it is above the x-axis between 0 and 2. So f of x is positive it's greater than or equal to 0 for 0 is less than or equal to x is less than or equal to 2. But the other characteristic for it to be a probability distribution function is that the integral in this part of the quadratic, so 0 to 2, of 3/4 x times 2 minus x dx has to be equal to 1. So this is slightly easier to integrate if I distribute. So I have 3 over 2x minus 3 over 4x squared dx, and integrated between 0 and 2. Antiderivative of this is therefore 3 over 4x squared minus 1 over 4x cubed, evaluated between 0 and 2. When we evaluate that at 2, we get 3 minus 2. When we evaluate it at 0, we get 0. So yes, this is in fact equal to 1. So this is a probability distribution function. It qualifies. If I want to find its expected value then, so the expected value of x is going to be the integral from 0 to 2 of x times f of x. So 3 over 2 now x squared minus 3 over 4x cubed dx, which has an antiderivative of 1 over 2x cubed minus 3/16 x to the power of 4, evaluated between 0 and 2. Evaluated at 2, we get 1/2 times 8, so 4, minus 3/16 times 16th, and evaluated at 0, we just get 0. So the expected value is also 1. Now, it didn't have to be 1 for the expected value. It had to be 1 in the previous instance in order for it to be a probability distribution function. For the variance, well, this time I need the mean. So the variance is x minus 1 squared times f of x, which is 3 over 2x minus 3 over 4x squared. This one, I'm just going to find the integral using technology. I mean, you certainly could distribute it out, integrate it, so on. Using technology, I get a variance here that this area is 0.2. So the variance of this probability distribution is 0.2 with an expected value of 1. The last thing we want to do in this question is find the probability that x is between 1/2 and 1. So the area under the curve between two values represents the probability that you would find a value between those two values. So what is the probability that x is between 1/2 and 1/2, and 1 is going to be equal to the integral from 1/2 to 1 of my original probability distribution, which was 3 over 2x minus 3 over 4x squared dx. And we already stated what the antiderivative of this is. So this is 3 over 4x squared minus 1 over 4x cubed. This time, though, evaluated between 1/2 and 1. I'm expecting to get a value between 0 and 1 because this is representing a probability. So when it's evaluated at 1, we get 3/4 minus 1/4. When it's evaluated at half, we get 3/16 minus 1/32. So just very quickly to figure that out, 3/4 minus 1/4 is obviously 1/2 minus 3/16 minus 1/32. We get, as a fraction, you can either say this is exactly 11/32, or you could give it as a decimal, 0.344 if I round to 3 significant digits. So that is the probability that a value would be found between these two values. The most common continuous probability distribution that you may have already encountered is the normal probability distribution. And that function does meet all these criteria. The area completely under curve is equal to 1. And then the area between two values will represent the probability of a value occurring between those two values. The normal distribution is an example of distribution function whose domain is from -infinity to infinity. But many of them that you will encounter will have much more restricted domains.